Now the next set of instruction is our branch instruction. This is mostly test and branch. The important part of these, you need to, when you read this section, possibly just concentrate on this part and a little bit on this part. You need to understand that. Rest of them, just don't worry about these things right now, because they're like needs more advanced architecture knowledge to understand those kind of things. So let's see what it is telling. Okay, so usually the branch instructions are something like this in a high level sense. So in Java, whoever knows Java, probably it doesn't make sense to you, but there is something in the C called go to instruction. Okay, go to some level. Okay. Now here, this branch instruction is something like this. If some test, let's take the same thing, a less than b. Okay, go to loop 1. Okay, now there is, we can do a loop 1, which is some instruction. Which, let's say, has some certain instruction. Okay, set of instructions. So here in the middle we can have like multiple other instructions written there, and then in the loop it will go and write some other instruction. Okay, so here what it tells is that if a is less than b, then jump to the instruction as labeled as loop 1. Okay, jump to the instruction. So this is purely like C high level, what I'm talking about. C has these kind of construct there. We don't usually use it, and it is not very recommended from software engineering perspective to use them and the high level language. However, these things are there, and sometimes in some cases possibly it cannot be avoided to have a go to instruction, especially when programming at the very device level, like device driver level, that kind of programming area. Now in terms of the branching statement that processor support, okay, these type of high level things can directly map into assembly language. This is exactly like branch on less than, BLT. So we are providing, like, let's say two variables, let's say R6, sorry, S6 and S7, loop 1. Okay, so this is exactly, this line is exactly replica like this. Okay, so this guy will ultimately mean BLT. For example, this one means if my $S6 is less than $S7, go to loop 1. Alright, so this is one instruction just to jump, test and jump kind of stuff. Alright, now the point here, another point here to be noted is that how far we can jump from a location. Right, so in the assembly code you have like possibly some set of instruction before, and let's say you have a level like level 1, and then you have BLT. Let's take the same thing, right? Level 1. Then you have and then possibly you have another BLT here. Okay. Now here what this thing is doing is that I have a label which can be can occur before my test and jump. Okay, so I'm going to a previous instruction back and redoing all the instruction, right? Or I can have certain instruction like, okay, test and jump forward. Okay, so this is test and jump backward, and this is test and jump forward. So essentially, if you recall, this one is actually we are constructing a loop. Okay, why? How it's so? So any test and jump can such construct can give you a loop essentially. So this one, if you think in a high level sense, this specific set of instruction is equivalent to this. Do some set of instruction while S6, let's say A less than B, right? Why it's so? Because after the level, these are the set of instruction I'm grouping, and here I'm testing if these say S6 less than S7 go back to level 1. Okay, so let's see what it translates in the high level sense, what it is the high level sense. Okay, high level, I have level 1 in the C, then some instruction. Okay, group of instructions, then I'm testing if A less than B go to level. So isn't this one do while loop, which is a valid construct, usual thing we do, either while something they do, then do some block, or do and while, or repeat or until, those kind of construct in the high level language kind of boils down to like test and go to a level, test and go to a level. Okay, so under the level in the C we have same set of block of instruction, and then after that we have a conditional test. If A less than B, go back to this level 1. Okay, so this is same as this, right? So when you write a program in the assembly language, so you first think of how you are going to write it in the high level construct and map those construct back into the low level instruction. Okay, first of all, anything with the while loop, anything with that kind of thing, you first convert it into this kind of statement, like I have a level block of instruction, after that I'm testing condition for the loop, then jumping back to that level and doing that. Okay, so this is kind of loop construction in the assembly language. The other one, which is a forward jumping, which I'm talking about here, which is practically saying is this. This is more like if okay, let's add one more level here. Okay, level 3, and under that some instruction. Under level 2 there is some instruction. Now this is saying if $6 is less than S7, go to level 2. Now my level 3 is some instruction. Level 3 is some set of instruction, and level 2 is some set of instruction in the high level sense. Okay, this I'm all talking about the high level sense. Now in this piece of code, what we are trying to do here is, and let's add another level 4. Okay, now we are kind of seeing here that if this condition doesn't hold, then it will go and start continuing doing this, right, doing this block of instruction. Then of course it will go and do this block of instruction. Okay, now this one, if I, then we have level 4, then some block of instruction there. Okay, now if I just put a go to here, go to level 4 from here, so what I am constructing in a very high level sense. So here I am doing if some test is true, then go to level 2, else level 3, and then after level 3 you go back and skip the level 2 and this one. So this is kind of a acting as a false statements, or false statement instructions of, let's say, else part. That is the if part, right? So as if we are, this is equivalent to writing if $S6 less than $S7, then whatever you do in the level 2, else whatever you do in the level 3, this thing, right? So if we have in a high level program, if you have something like that, if S6 is less than S7, then do some set of instruction, else you do some instruction, then you can always rewrite this part, breaking down into more fundamental operations like if S6 less than S7, go to level 2, which is the true part, or if part of our high level block. The else part come here, and after the else part you put a go to statement which jumps after the level 2 code. So this is like more implementation at the low level, and now we can directly translate this guy into instruction like a BLT S6 S7 go to L2. So this becomes your if part, this is else part, and we need to put, we'll come to that like a jump statement level 4. Okay, so this whole thing is your if then block. The point here, you note that with the same BLT test and jump statement, we are able to implement a loop, right? We implement a loop like a do while loop, or we can implement a if then else block. So this is a very powerful statement here. Okay, you need to use it quite often to implement this if then else block or the loop in your program. Okay. Now the question here, the statement here in this part, it is what it is giving is that in both the cases what we have seen is that either we can jump back or we can jump forward from one test point. Question is, what is the limit of the jumping? Okay, since this BLT or branch and test and branch instruction uses 16-bit offset field. Okay, so this, how much we need to jump, it is already encoded in the instruction. So it is like 16-bit, which is like 32K, is it 32K, Okay. Now, since we can jump forward and backward, it is a 2's complement number, so we can represent this offset as a negative offset to jump back and positive offset to jump forward. So it is basically, we can do a minus 32k to 32k, sorry, 16k to 16k, forward and backward, roughly. I think that would be the one instruction mismatch. You always know that 2's complement actually hosts one more number in the range. Like, for example, 2 to the power 8, like 8-bit 2's complement can host minus 127 to plus 128. So one more at the positive range. But roughly what I'm talking about is that from a distant jump point, we can go back till 16k instruction and go forward 16k instruction. And the point here is noted is that this is not a byte, okay, not the 16k kilobyte forward location and 16 kilobyte backward jump. It is not byte. If you remember, each of the instruction is 4 byte. That means you might want to think, okay, since it is each of them 4 byte, we'll probably can jump back and forth, divide by 4, like minus 4k to plus 4k. So it is not. It is in the number of instruction we can jump. Don't talk about the byte relation in the actual hardware. What it is all saying is that I can jump back and forth 16k above and 16k below. 16k instructions, not 16k byte. Okay, so that is one it is trying to emphasize on. And also, as we have seen that other part, this part, it is saying that we don't usually specify a number. We should not. We should always use a label there, as I have told you, and let assembler figure out what this number is. Okay, it little bit on the architecture dependent number that we need to put on, and if we don't know the internal architecture and how these branches works, we won't be able to compute that exact number. Okay, so for our purpose, we'll stick to the label format like BLT, some comparison between some set of 2 registers and where to jump in terms of levels. So that means another things will come up is that we'll have like multiple levels in the program. So you need to be able to manage the names of the levels, which means that just don't put arbitrary name on the level. Okay, put a meaningful name. So from the label itself, you'll have certain idea what that part is doing. Otherwise, a complex assembly program can be so big, and if you just keep on giving arbitrary name to the labels, it will be all mixed up and it will be all confusing at the latter point of time to yourself. Okay, so I would say put a meaningful name to the labels, and you can put any string there, so or big string or small string, doesn't matter. Okay, as long as you can understand.